about that? So yes, I can. So welcome back. Slope standard error. So standard error of anything is how far off, on average, that estimate is expected to be in any sample relative to what it's supposed to be in the population. So more technically, a standard error conveys the expected standard deviation of a parameter's sampling distribution. So like if you did the same study over and over and over and over again, you're not going to get the same answer for what the slope is. The standard error conveys the expected deviation from the correct answer that you would see in any one sample. So expected inconsistency is a phrase that I say repeatedly that sort of captures that same idea. So does that help? Folks who are asking questions about standard errors. You want to talk about p-values too? Maybe?
Yes. P-value of the slope.
Yeah, let me pull up a picture of when we first started talking about standard error here. 1 second, and I'll get the screen share going too, so we can all look at the same picture. Okay, here we go. Let's see if we can get from a maybe to a yes. All right, I am in lecture 2. And so this picture is describing the expected sampling fluctuation of a mean across samples. So in this case, what I had done is, let me back up a couple slides here. Oops. I had simulated 2 fake distributions, samples of 100,000 people, where the mean is supposed to be 10, and on the left side here, the standard deviation around that mean is supposed to be 5. So standard deviation, again, tells you the expected difference from the sample mean for any person's observation. So how far off are people on average from the mean? That's standard deviation. And then this picture is the same mean for the distribution, but a tighter standard deviation of 3. And so I had made some repeated samples then. This is slide, what am I on? Slide 17, where I drew samples, say, of 5 people, 10 people, 15 people from each of those 2 distributions. And what happens is that the fewer the people you have, the smaller the sample, the more noisy each sample's estimate is going to be. There's a bigger difference across samples in what you get, so sort of the spread this way. And if you have a larger standard deviation, so if people are more different from each other within a sample, then you have larger spread as well. And so in these sorts of pictures, the average distance of any sample's mean from the population that it should be is given by the standard deviation of the sampling distribution. That's what standard error is supposed to convey. So a standard error is how far off the sample version of something is expected to be from the population version on average. So if I have an intercept, it can have a standard error. If I have a slope, it can have a standard error. So it always refers to the parameter in question as being off from the population version of that parameter. Okay, did that turn it from a maybe to a yes question mark? In relation to the p-value. Okay, so standard errors and p-values are 2 different things. They are related, though, in that the standard error is one of the ingredients. So if we have, I don't think I need this anymore. If we have here we go. Let me pull up an example real quick that has a p-value in it. We haven't talked about this yet, but this is the same model we ended up with at the end of example 4b. So here's an example table of my solution for the fixed effects, where I have an estimate and a bunch of slopes. So I have an estimate for each of my slopes that tells me the change in y for a 1-unit change in each of these x's. Then next to it is the standard error for the expected inconsistency of that estimate across samples. So for the best guess for this sample is -0.4, the expected inconsistency across samples is 0.12. So that's the expected sort of wiggle of the slope around what it's supposed to be. And if I take this estimate and I'm testing it against a null hypothesis of 0, and I divide it by the standard error, that's what gets me my friend t. T tells me how many standard errors away from the null hypothesis I am. And so then the p-value that goes with it is the probability that you would find a slope this big if the null hypothesis were 0. So is this sufficiently far away from the null hypothesis that we would say it happens unexpectedly enough, where unexpectedly enough is your alpha level? So less than 5% of the time, we say it's far away enough from the null hypothesis that we would call it significant. So if you have a larger standard error, that's going to make it harder to say that something is significant because it's more unexpectedly different across samples. There's more noise to it than relatively speaking. So p-value is always the probability of finding what you found given that the null hypothesis is true. In most cases, we're talking about the null hypothesis is of 0 relationship. Okay, what else can I talk about with respect to homework since we're on this topic? I have it open in case anyone has.
The difference between the p-value of the slope and the p-value of the model.
P-value of a slope versus p-value of a model?
Yeah.
So they're both talking about how likely it is that you found what you found relative to a null hypothesis. For the model, the null hypothesis is that the R-square is 0. So it's talking about all the slopes and how they work together to predict the outcome. So the p-value that goes with the model, for instance, this one right here, this is testing all the slopes simultaneously against a null hypothesis of 0. So this reflects the contribution on average of any one slope out of the 5, because it's a per slope hypothesis that F is referencing here. It's a per slope, like did you get a good deal? So this p-value goes with this F, but it means the same thing. It's the probability of getting an R-square this big if the true R-square were 0. If the null hypothesis were true is the key thing here. That's the anchor point that we're landing on. How likely is it that we found what we found if the null hypothesis is true? Okay, other question, computation of question 50. Let's go to that. Got to find it first. Ah, yes. I've answered quite a few questions on this one. So this is asking about the comparison of the two latter fear groups, moderate versus severe. If you did your coding right per the instructions, this is a model parameter. So in this homework, I asked you to do sequential coding. Where is it? Yes. For fear of statistics, create 2 sequential contrasts using little as the reference group. So little versus moderate and moderate versus severe. So under this coding scheme, you indicate, the slopes indicate adjacent differences instead of differences relative to a single reference group. So you had to do this for the mom ed variable in homework 4. And that you can visit the happiness example in example 3, I think. That one had 5 categories and this one only has 3, so it's simpler than that. But in terms of what the coding would look like, you've done this before. If you set up your coding using indicator coding where it's each group relative to little, then moderate versus severe is going to be a linear combination that you can get the same way that you got the differences among the non-reference groups when you did the golf homework or when we did example 3 working class. That one was using indicator coding instead. And one question, why is the numerator a smaller number than the denominator? Degrees of freedom, is that the context? In degrees of freedom, oh, hang on, come back, here we go. So degrees of freedom for the numerator is referring to the top of the ratio that forms F. That's the number of slopes you spent. So if the F is for the model, it's the number of slopes in the model. If the F is for the increment to the model after adding additional slopes, then it's the number of slopes added would be the degrees of freedom. Either way, the denominator degrees of freedom represents the number of slopes you still could add if you wanted to, which is sample size minus the number of fixed effects already estimated. So in this table, there's 550 people altogether. It's 549 here because I always have an intercept in the model. So that one is always there. The question is, how many other slopes did I spend? I spent 5. There's 544 left that I could add. And if I added 544 slopes, then the model would perfectly recreate the outcome because I've just essentially spent all of the information I could. So it's not a prediction. It would just be like a rearrangement to get to the exact same place. Okay, more questions? If we used indicator coding, how do we get the standard error in that case? In that case, let me see what I have. Yep. Indicator coding was used in this example that I'm in right now, which was for dementia groups. So each of the groups was relative to none as the reference. And so to get the difference between the non-reference groups, that would be a estimate statement in SAS, so -1 versus 1 for the two groups that you want the difference for. It would be in Stata a Lincom statement, and in R it would be GLHT. Where did it go? I have it here somewhere, I think.
Domain.
Yeah, there it is. There it is. That's the missing group right there. So yes. So there's the only thing that's new in Homework 5 relative to what you've done before is the idea of adding in an F-test for the contribution of the new terms at each sequential step. Let me open up Lecture 4 real quick. There's one slide that I want. Not that one. It's close to it, though. This one. This is slide 30 in Lecture 4. So the idea of testing the change in the R-square, that's the new thing in Homework 5. Because you add in motivation after the empty model, and then you're adding in both GRE scores at the same time. So the question of whether those set of two new slopes improve the model, you have to ask for a test of those two new slopes together. And so that's the idea of testing whether the change in R-square when you add two things at once is significant. And that is done via SAS contrast, test in Stata, or GLHT in R, where you're listing each of the individual slopes. And so there are examples of those statements in example 4A as well as 4B as to what they look like. But in each one, you just list the two new slopes that you added to the model, and the F for them then should have as many numerator degrees of freedom as you added slopes to the model. Okay, let's scrolling through the chat window. I think I'm caught up, but let me know if I missed your question. So that's the only new concept, is the idea of testing a group of new slopes for their contribution to the model. And the change in the R-square you can get directly from subtracting the R-square in one section minus what it was in the previous section when those slopes were not included. Okay, what else? What else can I review or tell you about? See people typing. Maybe there's a question coming. If not, then I have some other stuff to talk about. Well, while we wait to see on that, I wanted to draw your attention to a deal I'm willing to make you guys. Want to know what my deal is? Okay, here's my deal. This weekend, you should have gotten a request to complete course evaluations from our university. I'm going to offer you a deal. I'm someone who believes strongly in good response rates for surveys. So no matter what you want to say on your evaluation, I want you to complete it. So I'm willing to make a deal. There are 26 people in this class. If at least 24 of you complete a course evaluation, everyone gets 1 point extra credit. That's the first part of my deal. Now on the icon, I can tell how many people have completed an evaluation, but I can't tell who they are. So I'm going to ask you to rely on peer pressuring each other to make sure that you can have a collective group benefit of 1 full point extra credit for doing it. The course evaluations are used in a number of things, such as merit review and faculty evaluations. I'm interested in your comments just as much as the numbers. So I encourage you to be as thorough as you would like to be in describing what works, what doesn't work, and suggestions for the future. It used to be the case that the university allowed us to add questions to the evaluation forms, and they took that privilege away. So because I have more specific things that I want to know about, I'm offering you a second deal. Tomorrow, you will be getting an invitation to complete a Qualtrics survey about this class. And it has more specific questions on it, a lot of which are open-ended. And the way that it's set up is that I fed it your email addresses, and it will tell me who has, if each email has completed a survey, but the answers are not linked to the survey. So it's still anonymous from that perspective. So if you individually complete the Qualtrics survey, I will give you a second extra credit point in exchange for your effort. Because I take your feedback very seriously, and I want to reward you for spending time in providing the feedback, because that's an extra ask, especially this time of year. So that's my deal. 2 full extra credit points if everyone cooperates with respect to evaluations. University evaluations close at the end of classes. The Qualtrics survey is going to stay open until the end of finals week, so you'll have extra time to complete that. And as I mentioned before, but just to remind you, I will be having office hours during finals week for both classes on Zoom during the time I would normally be teaching. So Tuesdays and Thursdays on finals week from 12:30 to 4:30. I've heard from Nikki that she intends to hold office hours that week as well, and I'll find out about the other TAs if they're available too. So if you're somebody who needs to get caught up, I want you to get caught up. I would like to turn in grades that don't have a distribution to them. I want to turn in an A for everyone. That is my goal. But the only way that we can do that is if everyone gets their work done. So I'm willing to have extra time during office hours on the finals week to make sure that we can get everybody to get done. Maybe the responses can be used as data for next year's homework. Ah, yes. Now that would be an interesting analysis. But speaking of next homework, your last homework is almost ready. I will let you know when it's ready. It will be due at the end of finals week. Your last formative assessment is ready, and that is available to you to be due on Monday night. To help you with it, though, note that I have posted Formative Assessment 6 Starter Kit on the website, because I'm asking for equations and estimate statement type things in the formative assessment, and so I wanted to give you a framework for what that should look like. So let me pull that up real quick so I can show you. 1 second. Here we go. So what I'm going to ask you, this is what we're going over today and Thursday. Given a linear model that looks like this, I want you to tell me how the model would predict an outcome for somebody, at least for question 1, with this combination of variables. And so the equation would look like this, where your job is to fill in the terms in parentheses. And then also to write how you would ask for this in software using whichever version you've decided to learn this semester. So if I wrote an estimate statement for creating a predicted value, it would look like this, where you'd fill in the underscores. If you were going to write a LINCOM statement in Stata, it would look like that, minus the semicolon. And if you were going to write a GLHT statement in R, the interior of it would look like this. So this is what I mean by write a programming statement, is one of these three. So this is a Word document that you can use as a structure. You can copy it over and put it in icon for the quizzes. So then, for instance, write the equation for a predicted G slope for somebody with an F of 2. That's what we'll talk about today, a predicted F slope and a predicted I slope. So this is meant to give you a structure that you can follow then in completing your last formative assessment, which will give us extra practice with these sorts of interaction terms and how to get predicted slopes out of them. So this is available on the website for you to get some help with on the day that we're going to discuss it. So if you don't get it right, that's okay. I want you to try. We're going to go over it together. 2 points for trying and an honest effort. I will respect that. Okay, so got your deal, got your homework due tomorrow, got your next thing to work on. I think I'm caught up on all the announcements that have been living in my head. Any other questions or comments? Okay, then I will shut this down to preserve some bandwidth, and we can go back to playing in Lecture 5. How's that sound? Interaction terms, as we were talking about last time? Yeah. We'll look at some nice beach weather. This is where I wish I was. Wish I were? Yeah. If I'm making up words, then you can't expect me to get the subjunctive right. The only subjunctive that I get right is the guilt subjunctive, tense that my mother uniquely has invented. Does anyone else have a mother who speaks guilt subjective? It goes something like this. I thought you would have called by now, but I guess not. That's the guilt subjective tense. She's very good at that. I wish I were here. Yes, but I'm not here. But we can look at the blue sky and say, what do you remember from last week? I'll take words, gestures, letters, anything. We started talking about a new topic on Thursday. No one remembers anything, or no one's feeling brave? Interactions. Yes, we did talk about interaction. What's an interaction? Margins, we did talk about that too.
So each beta are interacting with each other?
Yeah, the two predictors.
Yeah.
So the idea that we create a multiplicative combination of two predictors, and we give that multiplicative combination its own slope, called an interaction term. There's only 4 kinds, yes. You want to say it with me? The 4 kinds are more positive, less positive, more negative, less negative. That's it. You just got to figure out which quadrant you're in for those 4. Unique conditionals are specific to each predictor. Yeah, how we talk about slopes in the presence of an interaction has changed. So there's 3 sort of classifications, I would say, of slopes. There's bivariate marginal, meaning there's only one slope in the model, so it conveys its full bivariate relationship with the outcome. There's unique marginal, which is what we've had up to this point. Each slope is controlling for all the other slopes, but the slope is for everyone. So like this is the slope that describes the effective age, period. This is the slope that describes the effective grip strength, period. Then there's unique conditional, which is what happens when we get into interaction terms. And that is, the slope is conditional on any predictor that it interacts with being 0. And that's why centering matters so very much. Margins, we did talk about last time. That's how we're going to get predicted outcomes as well as predicted slopes out of interaction models. What is a synonym for interaction that starts with an M? And don't say mediation, because that's not it. Moderator, yes, moderation. The idea that the effect of a predictor depends on another predictor. So let me get, I'm gonna open up Excel here. We'll do a little, you liked the examples last time, right? Did I hear that feedback? Yes, examples are good? Let's do some more examples. Why not? So if I had something like, I'm just going to type, we wanted to predict, the one that we had last time was class performance. I'm going to do cheaty type here since it's faster. We had something like camera use, and we had class size, and size like that. So if I had a linear model that looks like this, there we go. Beta 0, what's that? What's the vocabulary word that goes with that idea in the notation? What's that thing? Intercept, yeah. I'm going to type fixed intercept because it's one number that applies to everybody. It's an estimated constant. And what's it going to be? Yeah, I'm going to change this to be grades. Let's say that. Class performance. Fixed intercept tells me what? Right. Grades when? Yeah, cam 0 and size 0. How do I know what 0 means? That's up to us. I control what 0 means. Do I have to do anything further to make this conditional on for beta 3? Nope, because if I just have these two already, this is just the combination of the two. There's nothing different. Okay, beta 1. That's a fixed slope of camera. So I'll start you off here. Change in grades per unit camera, whatever that means. So it have to be like an amount or a frequency or something. Am I done or do I need to keep typing? Here's my cursor. Yeah, I got to keep typing. When size equals 0. So this is an example here. Beta 1 is a unique conditional effect because it's describing how camera use relates to grades after controlling for class size. But more specific to that, because camera and size interact, the only situation in which beta 1 describes the full effect of camera use is when this term drops out, and that term drops out when size is 0. Okay, how are we doing so far? Okay, next up, beta 2. Fixed slope of size. Same thing, change in grades per unit size. What's the end of my sentence? When cam is 0, yeah. Same idea. So those are both conditional because they're part of an interaction term. The tricky one, beta 3, is also a fixed slope. And it's also an interaction term. Those words, interaction term is applied to a slope that describes the multiplicative combination of 2 or more variables like that. So do you remember what beta 3 is for? Its job is to take each of these main effect slopes and do one of 4 things to them. Make them more positive, less positive, more negative, or less negative. So we put signs in here before, right? So do we think that camera use is related to grades? And I can make this joke again because more of you have your cameras on. Some of you do. Come on, that's funny. No? Delayed reaction? So what do I put here? Plus sign, minus sign? I'm going to put plus here. It's my show. What about class size? Is class size related to grades?
We have decided no.
Yeah. I'll say no. Maybe a minus? Okay, we got to vote for a minus. It's fine. So then, make a space in here. So then the pattern, if camera use matters less in larger classes, what sign is this? If camera use matters less. Yeah, this one, it's going to be a negative. That's my trying to make a negative there. Because it's going to take this positive slope and make it less positive as size increases. So this would be a story where it's a less positive hypothesized interaction. If so, then simultaneously, if we talked about these two, then this would be a more negative. It would be the effective size is negative, and it would get worse as camera usage goes up. So each interaction term does two things at the same time. It moderates the slope of one of its predictors, and it moderates the slope of the other. So the way that I would talk about the interaction term is, first we could talk about it as moderating camera use. So I would say that it's the change in beta 1 per unit size, or it's the change in beta 2 per unit camera. It does the same thing from two different perspectives. So the bigger picture is that you can't just look at this slope right here and know whether or not camera usage matters. It's conditional on what size of class you're talking about. Likewise, we can't just look at this slope here and say, what is the effective class size? It's conditional, according to the model, on camera usage. Okay, how are we doing? Sideways? Sideways is what I'm hoping for. Like, that's my ultimate goal this week is sideways thumb. If I get anywhere past sideways, then I'll feel good about myself. Want to do another one? Okay, new sheet. This is a story from my past, someone's dissertation that I helped with once upon a time. The outcome here is psoriasis severity. The predictors are stress, which is thought to exacerbate psoriasis severity. I'm going to shortcut we'll do it properly. Beta 0 plus beta 1 times stress. And the question was whether personality characteristics like coping skills could mitigate the effect of stress. This is what's called a buffering hypothesis. So we'll do the same setup here. Stress, coping. So stress is bad for you, right? Can we all agree on that point? I'm going to put my psychology hat back on for today. So in this case, because the outcome is something that's bad, more is worse, I would say that there's a positive slope here. More stress is thought to lead to worse psoriasis severity. What about coping? Should the last one be beta 3? It should. Thank you. Is coping good for you? Talking to the counselors in the house here. Coping is good for you, right? So what do I type here? Is this a positive or a negative? Negative, because the outcome is severity. So more coping should lead to less severity. So then my interaction term. If coping mitigates the effect of stress, what direction is my interaction term going to be? This is going to be a negative one. Yeah, because it reduces the effect of stress on severity. So people who have more coping would have a smaller beta 1, essentially, as it trickles through the system. Yep. What if I changed it to be something more positive, like psoriasis health? Then that flips. That flips. Hang on. That looks like a happy face with one eye. And then this one would flip too. Yep. So then this would be an example, if it were worded in this direction, of a less negative. The effect of stress is negative. It would become less negative as coping increases if this interaction term were positive. What about if we approach it from this way? Beta 2 is already positive. What's the interaction term going to do to it if it's a positive number also? This one's a more positive. So the effect of coping would be strengthened in people who have higher stress levels, according to this model. It would become even more positive via the interaction term. So there's lots of examples of this in life. Here's another one. Let's go with, okay, functioning equals, oh, hang on. I'm going intervention design on here. You guys don't have the model to go with this yet, but you can understand the concepts just fine. Let's say that I'm doing a longitudinal study, and I'm looking at the effect of a new treatment on functioning in patients who are losing their functioning over time, like something like maybe ALS or some other sort of degenerative process that unfortunately reduces people's functioning. Isn't stress negative? Negative types positive. Stress is negative, so this would be a less negative effect if we had a positive interaction term, if that's what you're asking. If we followed...
I guess what I was imagining was the stress is a negative, the coping's a positive, and then when you multiply stress as a negative times coping the positive, I thought maybe that would turn into a negative. I don't understand why positive is right there.
Yes, so this is meant to be what beta 1 becomes. I just didn't want to overwrite this part of it. Not what the variable is, but what the slope is.
Oh, okay.
Yeah, if this were a negative number in here and this were a positive number in here, then yeah, the result would be negative.
Okay.
But I was trying to abbreviate what the slopes were going to become. And this is the problem with crappy notation done on the fly. It's ambiguous. So maybe now you can appreciate the loveliness of equations and their specificity. But I'm trying to do example time here. It's like story time, but with more sadness. Something like this. So let's say that I have a clinical trial. I'm trying to compare the utility of a new treatment versus standard care for reducing the decline in functioning over time as a disease process. So if I have somebody who is supposed to be losing functioning over time, I would expect maybe the slope of time to be negative. If treatment is supposed to help, I would need to know at what occasion time 0 is in order for me to interpret what this means. Because if its time 0 is at the beginning of the study, then I would actually expect a 0 slope for treatment if they were randomly assigned. Because at the beginning, there should be no effect of treatment if you've done your random assignment correctly. But if treatment is supposed to help reduce decline over time, what pattern do I have here? Is this going to be positive or negative? The idea is that people are going to decline in functioning over time if left unattended. My hope is that the treatment will reduce the extent to which that occurs. So what's my sign? Well, if I put a negative here, then what that would mean is that if I'm talking about treatment being the one group, for instance, then they would have even more decline over time. Yeah. So this would be a less negative story. As time goes on, people lose functioning. They lose functioning less if the new treatment is working. So if the answer to the question, which pattern is this, is more something, more negative, more positive, then what the interaction is doing is making the effect stronger, further away from 0, as the interacting variable increases. If the answer to the pattern is less something, less positive or less negative, then it is weakening the effect as the interacting variable increases. And eventually it would flip over into the opposite direction. So less negative, if you keep going up, you'll hit 0, eventually will become more positive. So you're moving one way on the number line versus the other. But I would argue there's still utility in talking about it this way. Because if you say something declines less, that is not the same thing as increases. Think about it this way. Do you remember the Weather Channel? Like back in the day when the only way you knew what temperature it was to hope that it was on the 8s and you turn on your television and you find out what the temperature is? The way they word things is similar to this. In the middle of winter, they will give a forecast that says, not as cold, because it's going to be 30 instead of 20. They don't say warmer. They're not trying to, kid you. 30 is not warm, but it's less cold than 20. Likewise, in the summertime, if it's only going to be 80 instead of 90, it's not as warm. So that is paying attention to sort of where the anchor point is and then going relative to that. Declines less is not the same thing as grows more, even though they're heading in the same direction on the number line. Okay. How are we doing? And my watch says it's 52 degrees. Amazing. So in these models, this beta 1 and this beta 2 only give me one possibility as to what the effect of that predictor is, but the model tells me that there's infinitely many more. Because this is specific to when the interacting variable is 0, I could ask for what it is when the interacting variable is 1, when it's 2, when it's -1, when it's whatever. So I want to show you how to ask for other slopes beyond just the ones that are given by the model. Like in this example here, if I wanted to know what is the rate of change in the treatment group coded 1, what I'd have to do is add together this slope and this one. Those two terms together would be a linear combination that would give me the effective time in the treatment group. So I want you to be able to do that as well. So let's play. This is the version of the PowerPoint where I was typing in last time, so we have that one as well. So here's the 4 kinds of interactions. We practiced that. And we went through another example looking at the effects of attitudes in education. Do you remember this before, maybe? This was a demonstration as to why centering matters. Because the intercept is specific to when the predictors are 0. When a predictor is part of an interaction multiplicative term, its slope is specific to when the other predictor it interacts with is 0. So if we don't have meaningful 0 values for our predictors, then 3 out of the 4 fixed effects are going to tell us nothing useful, because they pertain to interpretations that are either unnecessary or not possible. Like attitudes is measured on a 1 to 5 scale in this story. So to know what the slope of education is when attitudes is 0 is not a helpful thing to know. It's not possible. So centering is used to make sure that all of the intercepts and slopes refer to possible values within your model, but you can ask for what the predicted slope is going to be as a function of an interaction term always. It's a linear combination, just like you already know how to do. So I want to start then on slide 16, a little bit of practice with asking the programs to give us predicted outcomes, as well as predicted slopes, which is a new thing. So do you want to play along with me here? A little more active typing, if not active learning. Active typing is about as active as I get right now. Let's put it that way. I look at my watch and it's like, are you alive? Because you've only moved like once in the last 6 hours. But thanks to you guys, I burn like an extra 300 calories on the days I teach. Seriously, it's like cardio. So let's do some active typing. Here's my story. Predicted GPA, so this is like my Y hat here. And I am using the centered versions of these variables. So I've centered attitudes, which is on a scale of 1 to 5 at 3. Years of education, I've centered at 12, so the reference is someone who went to high school. And then my interaction term has the centered variables as well. So what we're doing on this slide is practicing how I would ask for a predicted outcome for any level of these predictors. So I've got SAS and Stata, and in R it would be the same idea, except the multipliers are just stacked into one little vector with not attached to their words. So it makes it a little bit trickier to fill in on the fly. But let's say I wanted to ask for a predicted outcome for somebody who has an attitude of 5 and an education of 16. So right away, I've done part of this for you. The intercept is in here. When you are creating a predicted outcome, the intercept is always included, because that is your baseline reference point. That's what the outcome would be when all the predictors are 0. The only question is, okay, how much further away from 0 am I on my predictors so that I would augment the prediction relative to this as a baseline? So intercept 1 always goes here. So if I want a prediction for GPA as my Y hat for somebody who has attitudes of 5, and it's centered at 3, what do I type here and don't say 5? So attitudes is centered at 3. I want a prediction for when it's at 5. I got a couple answers here. Got some votes for 2. Yeah, this is a finger question. Peace. Yeah, 2. Why 2? Because 2 is 2 more than 3, which gets us to 5. Likewise, if I want education of 16, what do I type here? Education is centered at 12. 4. Now this part, don't think too hard. What do I type here? 8, because 2 times 4 is 8. So I'm making this point because I see people mess this up a lot. the values that you're putting in are with respect to the centered predictors. So you have to do the math in your head as to what the centered value would be, given where you put 0. I'm also making this point because this is something that I screwed up. In the first version of your handout that I posted for this unit, I couldn't get the R plots to work, and so I just gave up and put placeholders in. It was because of this, because I was plotting centered values on an uncentered axis, and so the lines didn't show up. So even I screwed this up, is what I'm saying. But good, we got the hang of it. What if I wanted attitude of 1 and education of 12? What goes here? Yep, -2. Yep. Because attitudes is centered at 3, so I have to subtract 2 to get down to 1. What goes here if I want a prediction for someone with education equals 12? 0. And what goes here then? Yep, -2 times 0 is 0. Yep. Then last but not least, what goes here if I want a prediction for attitude of 3 and I've centered it at 3? That's a 0. And I have to space these over. What goes here if I want a prediction for ed equals 20? 8. Yep. And what's 8 times 0? There you go. So you've done this before. You've asked software to give you predicted values of various combinations. The only catch is that now your predicted values have to take into account the interaction terms. And you literally multiply the values that you already gave it for the pieces that go into the interaction. So every single term that's in the model goes in here if you're trying to create a predicted outcome, because the whole model contributes to the predicted outcome. If you leave something out, you are saying that it's 0. So technically speaking, I didn't have to have these here. I could have saved myself some typing because this is what would have happened had I not wrote them. But I like to list them all out because then it forces me to think, should that be 0 or should that be something else? Okay, how are we doing? This part's not so bad, right? So this is what I have a shorter way to show you in the syntax when you have multiple of these to do, but I'm just going with the concepts right now. How do we ask for predicted? The next thing I want to show you then is taking it to a level of abstraction higher. How do I get predicted slopes given this interaction term? So if beta 1 is only going to be the slope when education equals 0, how do I get it if education is 1 or 2 or 4? Likewise, beta 2 is only the slope of education if attitudes equals 0. How do I get it for attitudes equals 5? Same process, slightly different code. So here's my model again, 2 predictors and their interaction term. The rules for asking for model-implied simple slopes. So remember the term simple is a synonym for conditional, meaning specific to an interacting value of whatever you've chosen. The rule is every slope is a function of what it is plus what modifies it. So there's a 3-step process to figuring out how the model predicts a slope for any combination of predictor variables. Step 1, go into the equation and find all of the terms that have the slope you're interested in. Step 2, factor out that common slope. And step 3, you have the ingredients for what's left. So let me show you what I mean by that. Nope, too far. Okay, so if I want to get the slope for attitudes, here's how I do it. The logic is I go up here. I find all the terms that have attitudes involved in it. So I don't need this. I do need that. Don't need beta 2. I do need this. Okay, so that gives me this much. Likewise, if I wanted to get the slope for education, I go up to the model, I find all the terms that contain education, and I bring those down. So it would be these two. Step 2 is to factor out the variable that the slope is for. So if I want the slope of attitudes, I take it out of here, I take it out of here. I pull it behind, and what's left in brackets is the slope of attitudes according to the model. It's a linear combination of the slope of attitudes beta 1 all by itself, plus how the interaction term says the slope of attitudes changes per unit education. Likewise, if I want to go the other way, I start with this combination, I factor out education, and what's left are the ingredients to get the education slope for anyone as a function of their attitudes. And if I wanted to compute this correct standard errors for these linear combinations, here's how I would do it. A much easier way to do it, of course, is to ask the software to do it for you. It will get it right. But it is technically possible to do this stuff by hand if you wanted to. Okay. Want to practice? Okay. So again, here's my model. If I steal all the terms that have the slope of interest and then factor it out, here are the ingredients. So let's start with this one. This is how the model says the slope of attitudes should be constructed for any level of education. The slope of attitudes is only equal to just beta 1 if education is 0, because that's when this second part drops out. That's why we interpret this as this is the slope of attitudes specifically when education is 0. Likewise, if I want to talk about the slope of education, it's only going to be just beta 2 all by itself when attitudes is 0, because then this part drops out. But we can ask for what each of these slopes is at any level of the other moderating predictor. So these are different than what you've seen before in that we're not asking for a predicted outcome. We're asking for a predicted conditional slope. So I have taken the liberty of zeroing out the intercepts on all of these because we are asking for a slope. And beta 0 has nothing to do with my slopes. The rule is only terms get included that have to do with the slope in question. And at no point for any of these slopes is beta 0 going to be involved because it's not multiplying any variables. It's not a slope. For each of these words, they are referring to what their beta would eventually be in the analysis. The value that goes next to them, the multiplier, is for the variable that would be attached to it if there is one, and it's 1 otherwise. So if I want, for instance, the attitude slope for somebody with education equals 10, here are my ingredients. This word at right here stands for beta 1. So I need one of those. At a minimum, I need this to make an attitude slope. I need a beta 1. At a minimum. So for the same reason, I'm going to put a 1 on the next line because this is also talking about an attitude slope. Now the question is, what else might we need? Education, right here, is talking about beta 2. Is beta 2 in my ingredients here? Nope. It's a 0. And this is the part that is often very confusing, because it's like, wait a minute, don't we need, like, because it's ed equals 10, so don't we need something for education? We do, but it doesn't go with the main effect of education, because what we're ultimately interested in is the attitude slope. The moderator variable goes after the interaction term instead, because we're filling in that value for education as who do we want the attitude slope for? We want it for education equals 10. So given our centering, that would put this at -2. So only terms that have attitude as part of them could possibly have a number after it, because we're getting this attitude slope out of the model. This one is 0 for the same reason. If I want the attitude slope for education equals 18, given that education is centered at 12, what goes here? This is a 6, yeah. So step 1, go into the equation and find all the terms that have the slope you're interested in. Step 2, bring just those terms down and factor out the slope, the predictor that you want the slope for. The terms that are left are the ingredients to forming these statements. Now, what if we go the other way? Let's say that I'm interested in the education slope and I want it for different amounts of attitudes. Now, these are my ingredients. Attitudes by itself refers to beta 1. Do I need any of those if I'm interested in the education slope? I do not. Because now I want the ed slope. So any term that doesn't have ed as part of it is not eligible to be included. Ed stands for beta 2. How many of those do I need? I just need 1. At a minimum, ed slope is going to have to start with the ed slope that's in the model when it's by itself. The question is, what else does it need to get to the targeted level of moderation? Now, in this case, the value that goes after the interaction term is for the moderator. So if I want it for attitudes of 2, given that attitudes has been centered at 3, what do I type here? I type -1. And we'll do one more. If I want the ed slope, do I need anything out of attitudes all by itself? Nope. If I want the ed slope, do I need an ed slope? Yes, I do. I need at least one of those. Now, what else do I need? Well, I want it to be for attitudes equals 5, relative to a centering point of 3. That's going to give me a 2. So I want you to look at the pattern here. A more general rule that you can follow is if I'm asking for a slope of a variable, that gets a 1. to start with. Then what else is included depends on what it interacts with. The values that go after the interaction term are the values of the other variable, the moderator. So the first two lines, because I'm talking about the attitude slope, -2 and 6 refer to values of education. Flipping it the opposite direction then for the second two lines, because I'm talking about the ed slope, the values that go here are for the moderator of attitudes instead. So this idea in your formative assessment that's due next week, I'm asking for what is the equation for a slope and what would it look like in a programming statement. This is what I'm asking for. Equation 4 means figure out what the ingredients should be, and then how would I tell the program how to compute a particular slope for a combination of moderators. This is what we're going to practice with the formative assessment and go over. Question?
I'm sure I have the answer to my question, but I was curious, how does the model or the system make the difference between when, for instance, attitude is a value versus when it's just a, let's say, just one item instead?
Great question. So the question was, how does the system understand when I'm filling in the value for a slope versus a variable value?
Correct.
It's all contextual is the answer. So in this context, because what I'm trying to estimate is the slope for attitudes, it's like once I give it a 1 here, then to be internally consistent, this should be a 1 also, and then it has to be for the other variable. So in this case, this is the value of education that I want the attitude slope for, because the attitude slope is what I'm estimating. Here, I'm estimating the education slope, which means it's the value of attitudes that I want it for. So I would highly recommend building yourself something like this at first, when you first start doing these things, because this is the answer. The variable that it's the slope for has been factored out. The only thing that's left is the moderator variable value. So the numbers you're filling in are what go into these parentheses after the interaction term. It is very tricky, though, at first. It takes practice to get used to this. But once you get it right, you'll have it. And yes, you will get a chance to practice this in your very last homework. But it won't be that bad, I promise. It'll be okay. I promise. I want to send you off on a high note. I wouldn't give you like this killer total homework. And to prove it to you, here's the example that I started looking at. Let me show you what I did. For homework 6, like use this one, because we're at the point in the semester where scaffolding should not be subtle. Use this one. So I have an example that we'll go over that has actually 2 interaction terms in it, and it follows the exact same structure as your homework. So I will let you know when your homework is available, but I have an example for you to follow as per my usual. So we'll go through this here, and I've got 2 sets of models to go through. All right. So yes, this takes a little bit of practice, but key idea, to figure out how to get a slope, go into the model, find all the terms that have that slope in them, bring them down, factor that slope out, and then what's left is how the model gives you the coefficient that multiplies that variable. So the term in brackets is the model implied slope. That's what we end up with. All right. Questions? Any of that you want me to do again or more slowly or differently? question?
Intercept 0 means we're asking predetermined slope
It means that I'm asking for any kind of slope.
in the model.
So the reason that this is 0 is because I'm asking for a slope, not a predicted outcome. So it's a different context than what we did on the previous page. So this was the previous slide we filled in, where what I'm trying to get is y hat. I'm trying to get what the whole model says the outcome's going to be. The intercept goes into that. Everything goes into that. Every term that's in the model needs a value to be included to get a predicted outcome. What we just did is a predicted slope. And by the rules of go into the equation and find all the terms that have that slope in them, beta 0 will never ever be selected. It doesn't have a slope in it. So there will never ever be an intercept in an estimate statement for a slope. Likewise, if I go through this list, if I'm getting the slope of attitudes and I have a term in here that doesn't have that word in it, it cannot contribute. It's going to 0, or you can just leave it out entirely. So yeah, if the slope is for attitudes, only things that have the word attitude should have any kind of value after them. 1 when it's by itself, and then the value that goes as the multiplier is for the other variable, the value of the moderator. Okay. 313. That means it's time to be quiet. Don't look so disappointed. I know. I'm coming back on Thursday. That's how I'm interpreting those faces. Is I enjoy this so very much. I'm sad that it's over. Well, you know what? For you, I have a YouTube channel. You can enjoy to your heart's content. And in 2 more weeks, you never have to talk to me again if you don't want to. But I hope that you come back, because this is some cool shit, and it can get even cooler. But that my sales pitch for coming back is not until next week. I'm not going to do the hard sell right now. It's too soon. Okay, but it is garbage day, which means I say, see you Thursday. Let me know if you need anything. Office hours start shortly. Thank you for being here. Bye for now.